Now, okay, we will, any question here? No more? So, we will go right away to electron transfer chain. Can I erase this?
Yes.
Reduction and oxidation. Reduction na rin at oxidation na rin.
Okay, this is what happened in the electron transfer chain. Actually, this is just oxidation reduction reaction. Now remember, what is transported to the cristae are all electrons carried by the electron carriers. Now this time, the electron carriers are the net, which are produced by which are produced in the glycolysis and the Krebs cycle. So as with the FAD H2, which is said to be the FAD and the net are electron carriers. So they are brought, of course, with their electrons to the cristae for electron transfer chain. Now, this is what we call as oxidative phosphorylation. This means to say there is what we call as addition of phosphate. There is ATP generation. We will see how many ATPs were produced for one NADH and one 5-H2 that pass through this electron transfer chain. Now, the cristae consists of several electron carriers, actually. So not only you have there, of course, these are the NAD and the FAD, which catch the electrons from glycolysis and the Krebs cycle. And aside from that, we also have cytochromes. We have cytochrome B, cytochrome C, cytochrome A. These are also electron carriers. Of course, there are some other electron carriers here. But we're just emphasizing this. So you have here red meaning reduction, oxidation. When we say reduction, electrons are gained. They say oxidation, electrons are lost or given off. Okay? Now remember, the net and the fad are carrying the electrons. So what will they do with these electrons being carried by these molecules in the electron transfer chain? And of course, we also have oxygen. Now this is what happened, class. Now say for example, I am the NAD. It undergoes reduction. I am a reduced form of NAD, meaning I gained electrons. Maybe I came from the cytosol out of the breakdown of glucose from glycolysis, or it could be the breakdown of pyruvate. Now, when I am brought to the crystay, this is what I will do. Say, I am the NAD, I'm giving this to the fad. Okay, you accept this. Okay. Now me, I undergo oxidation. Fad undergoes reduction. Okay, so there is one ATP generation. Okay, fad gives this off to cytochrome B, and she undergoes oxidation and she undergoes reduction. Okay, cytochrome B to cytochrome C. Okay, she undergoes oxidation and she undergoes reduction. Cytochrome C to cytochrome A, she undergoes oxidation and she undergoes reduction. There is again another ATP generation. Now, from cytochrome A to the last acceptor of electron, which is oxygen, give it off. Okay, she undergoes oxidation and oxygen undergoes reduction. And when oxygen receives, so there is again ATP generation. When oxygen receives the electron, ikaw na ang last. No? Oxygen is the last acceptor of electron, then water is formed. The oxygen becomes water. Okay? So, my question. How many ATP molecules were generated out of one NAD H that undergoes or pass through the electron transfer chain? Okay, we will count. How many? 1, 2, 3. So for every NAD H, that will be multiplied by how many? 1, 2, 3. Times 3 times 3. So this one here times 3. So ilan na niya siya? 2 NAD H times 3 is 6. Minus 2. Kaya no minus 2 man? Less expense. Pag-transport. 2 ATP which had been used during the transport of this NAD H from the cytosol to the crystay. Can you still remember? The transport of this NAD H from the cytosol to the crystay requires 1 ATP per molecule of NAD H. So since there are 2 ATP molecules, 2 NAD H molecules that will be transported to the crystay, then that will be deducted in the total ATP generation for this molecule. So supposedly 6, then we will deduct it. So you have here a total of 4 ATP molecules. So you have 2 ATP, you have 4 ATP here, and then you have 2 ATP, then times 3 here. So 8 times 3 pila? 24. 24 ATP molecules. Okay. So you have here 4 ATP, you have here 2 ATP, you have here 2 ATP. Okay. Now how about for the 5H2? Now for the 5H2 class, the electrons will not be given back to the net, but it will be given to cytochrome B. Cytochrome B undergoes reduction, fad undergoes oxidation. Cytochrome B to C, reduction, oxidation again, Then cytochrome C to A. Here we have 1 ATP generation. Okay? Now from cytochrome A to the last acceptor of oxygen, there is again ATP generation. Now, my question, how many ATPs were formed when 5H2 passed through the electron transfer chain? Okay, there are 2 ATP molecules. So we will multiply it by 2. Pila? 2 times 2 equals? 4. 4 ATP. So we will tally all how many ATPs were formed out of the breakdown of a glucose molecule. 2 plus 4? 6 plus 2? 8 plus 4? 24?
32.
Plus 24. 8 plus 24 is?
32.
32 plus 4?
36.
Okay, that's why you have a net of 36 ATPs. Net, this is already net. Huh? Net ATP production per glucose molecule. So meaning, in every breakdown of glucose, that will give you a net of 36 ATP molecules. Some other books mention 38. That is still correct because they have not deducted this yet. It's not yet net. Yeah, they have not deducted this yet. But that is not the net yet. The net is 36 because in every transport of NADH, that requires, or there is a need of 2 or say 1 molecule of ATP. So since there are 2, then it uses during the transport 2 ATP molecules. So overall, we have a net of 36 ATP molecules for every breakdown of glucose. Okay. So any question? Now you have here oxidative. So this is the oxidative phosphorylation. Okay. Now this is actually how is this ATP generation being done? Okay, here. Now I think that is it's in there in your textbook class. ATP generation is explained through chemiosmosis. We have chemiosmosis. Now actually we have the inside of the cell. This is the cristae, and you have the intermembrane space. Intermembrane space here. We have the inside of the cell. So this is the intermembrane space, and this is actually the cristae. Now here, since cristae is the continuation of the inner membrane, so you can see phospholipid by layer. Are you with me? So makita niyo mga phospholipid by layer. Now, aside from that, there are protein carriers. As what I have said, these protein carriers will not only, or say, these are mga proteins, I should say, which may also carry the electrons. Okay, so you have here cytochromes, C, cytochrome B, cytochrome C, and then we also have here mga kenones. Other molecules, we have cytochrome A, and of course we have the oxygen. Now, during the oxidation reduction reaction class, electrons are passed from one electron carrier to another. So, what is left, say if this is the atom of hydrogen, and you have here the protons, which is positively charged, and of course the neutron. Electrons are here. This is our hydrogen atom. Now, when electrons are given off, they are given off. So, what is left are protons. Hey, are you with me? Because electrons are passed from, say, inside of the cell. or sa inside of the mitochondrion. Now, electrons are passed from one electron carrier to another. So, as a result, what is left here is the protons. So, muna ay positive. Dali. So, not a positive. Meaning, the electrons are ejected. No? They are now passed from one electron carrier to another. Now, with the, of course, with the increasing concentration of protons, because electrons are given up or passed from one electron carrier to another. Now, there is what we call as increased concentration of protons in this space, no? Inside the mitochondrion. Now, with this will undergo, so remember, you have, if you could still remember, diffusion. No? The diffusion is from higher to lower concentration. So,